Welcome to another episode of Black Guy Does Physics. But today we have Mr. Blank. He's about to give me some tutelage on what the heck I'm doing wrong here. So let's look at this question. What is this question? This question is from AP 2000, what was it, Roy? 19? 19, number 3, set 1, right?
Yeah.
So my kids, when they look at this problem, it like freaked them out. And if I was doing a test, it would freak me out too, because I'm like, what the heck is this? But how do we not get freaked out by a problem like this? Simply, if the diagram doesn't help us, then we go like, whatever, don't want to deal with you. Let's move it on, keep it moving. Right, Roy?
Yep.
That makes sense. Roy, would you be freaked out by this problem?
If I looked at the diagram, yeah.
Yeah, it does. So we just be calm, man, because real G's. When we go in the test, we remember that we're not taking a test. We're just putting down our answers. Okay? So let's get it cracking. So first things first that we have here, we always look at the diagram. If the diagram doesn't help us, we keep it moving. But there's a particular thing we see here. We're seeing something rotate. So once I see rotation, there's only two things that popped up in my head. I know it's torque, and you know torque could go to forces, and motion, angular motion. So if it's angular motion, then what I'm going to have is that they would have to give me some time or some distance or some omega or some crap like that. So those are the two things that I have here. So I don't know what's going on with the platform, so I keep it moving. I read, do the Tatiana here. Oh crap, I only have low battery. Sweet. So we probably only do up to C. But let's keep it moving. Circular platform with rotational inertia, IP, rotates. So I see IP, I know that's torque. So torque, I know that torque is equals to I alpha. Sweet. Freely rotating without friction. Vertical, a small motor-driven wheel that is used to rotate the platform is mounted under the platform and touches it. The wheel had radius R and touches the platform at distance D. Okay. From the vertical axis of the platform as shown above. The platform starts from rest. Usually when I see from rest, I know that this is going to go into motion. Usually if they're not talking about motion or energy, that's not what it's going. So at rest means omega 0 is equal to 0. So I'm good. And the wheel exerts a constant horizontal force. So there is a force, magnitude F tangent to the wheel. So when I say tangent to the wheel, that simply means that because the force is tangential to the wheel, I know that the torque that is produced is just R, which is the distance D, times the force. Because whenever you have a circle and something is tangential to the circle, then the R becomes the perpendicular distance, and you're good to go. Just remember that. Until it reaches an angular speed omega, P. So if it goes from omega 0 to omega final, which is omega P, that means that there is some motion there. And I see our sweet friend here, time. And once we see time, what that means, Mr. Blank?
It means motion.
Motion. All day, every day. During the time, it stays and there's no slipping. What that means again?
No slipping. It means that we can still use angular motion, and means V is equal to R omega, theta equals R, or X equals R.
Theta and A is equals to R alpha. That's what it means. Sweet. So part A, derive an expression for the angular speed omega of the platform. Express your things in these. Sweet. So they try to trick you by giving you this omega P and the T, and they're going to try to make you go to angular motion. But if you go with angular motion, you're going to have a hard time. So what I tell my students is that we always go with what is true up front. And what is true is that if I see some crap turning and there's a force, then that is always torque. Torque is my best friend. So I go with torque net is equals to I alpha. So notice there's no omega P in here. So I do a quick check. What is my torque net? That's just the force, the torques that's on there. So the torque that is on there would just be this would be D times the F. Mm-hmm. So it's R times F. And I already explained that it's tangential. My I would be IP. And my alpha, which is the angular acceleration, I know that there's only two places that I see angular acceleration. That is A is equals to R alpha, then all the motion equations. Right? So obviously I'm not going to use A is equals to R alpha. That doesn't make any sense right here because they told us to write it in terms of delta T. So alpha is equals to delta omega over delta T. And delta omega would be just omega p minus omega 0, where omega 0 is 0, so we're good to go. So this becomes df equals the IP omega p over delta t. And then we rearrange. My kids found something kind of weird. They gave you R, saying you should write it in R, right? They're trying to trick you. But you don't get tricked. You just keep it moving. All right? Determine an expression for the kinetic energy of the platform at the moment it reaches the angular speed omega p. Express your answers in terms of IP, RD, F, and delta t, and the physical concepts as appropriate. So let's get it. Kinetic energy is what? What is it?
Depends if it's linear or angular.
In this case, it must be angular, right?
Yeah, it would have to be rotational. So you'd have 1/2 I omega squared.
Oh, snap. And then I do a quick check. I know IP is IP. And omega p, we just did that. So that would mean I would have to rearrange that stuff and then solve. So that would give me 1 IP
And then that would be
df delta t over IP
squared.
And then I cancel out what needs. Sweet. The AP can be giving us these sweet questions. Right?
Mm-hmm.
Last part. There's more to this question, but we're going to keep this video short and then do the other part another time. We just want to test this out to see what's popping. Working on our chemistry. And yes, we have our mask on. Wear your mask, kids. Wear your mask. Derive an expression for the angular speed of omega w. What the heck is happening here? Let me slow down because I'm reading too fast and I don't understand what's happening. Whenever you're reading, if the first time you read it, it doesn't make no sense, stop reading, start reading again, and slow down. Derive an expression for the angular speed off the wheel. Okay, angular speed off the wheel, omega w, when the platform has reached an angular speed, omega p. So the platform is at its omega p. Express your answers in this, and any physical constant. So now I'm lost, right? Because I'm like, how am I going to relate the angular speed of the wheel to the angular speed of the platform? How the hell can I do this? That's a hint. Oh, there's a hint. Why would they tell you that? So in essence, we have to try and figure out how to relate those two things. Yeah? How we do that?
Would the linear speeds not be equal?
And why would the linear speeds be equal?
Because they have to be moving at the same speed if one's driving the other.
That makes sense. So what Mr. Blank is saying is like, yo, them things have to be equal, the linear speed. So that's something you have to remember. As I said in my class, that's like one of them little tidbits of information that some students don't remember, but you have to remember it. If two things are in contact, right, and they're driving each other, and there's no slippage. What no slippage means, hopefully I spell slippage correctly. If there's no slippage, it simply means that V is equals R omega, true. But if you're driving each other, they're in contact, then the only way something could not slip is that the speeds, in this case, the speeds of the wheel and the speeds of the platform must be equal. Mm-hmm. Right? So what's the speed of the wheel? The speed of the wheel will be R omega. So it would be R. Whoa, what was that? My bad. That would be R times omega w, right?
Yeah.
And then
has to equal the radius of
would
the
be
platform.
d, right?
Yeah, d
d
omega p.
Omega p, but we have omega p as df delta t over ip. And then we just solve for that stuff.
And we can solve for...
Alright, cool. That wasn't too bad. That was a quick tidbit of information. This was just here, so just to explain to you that when you see a diagram, if the diagram doesn't help you like explicitly, don't get scared. Just get whatever tidbits of information you can from it, and just simply, as the Greek god himself, Karim, would say, just write what is true. And what is true in this case? You see something spinning, so if you see something turning, there's only two things that is happening. It's either you're going to deal with angular motion or you're going to be dealing with torque. And then just move appropriately.
Actually, in this case, I'm pretty sure they want us to write in terms of dr and omega p.
Did I make a mistake?
No, it's the right thing. Just you have to keep it as omega
Oh,
p.
my bad. Thank you, Roy. I made a mistake.
Because they just asked for that.
Yeah. Oh, AP was being nice.
Mm-hmm.
Oh, omega p. I forgot. My
And
bad.
then you just omega.
Oh, sweet. That's even more.
Omega W equals d omega p over r.
That's even much simpler. Look at me trying to complicate my life. But thank you. So what we were saying before is like, make sure you don't get intimidated by anything. If you're doing this test, remember, it's not a test, kids. It's not a test. It's just a place for you to put your answer. Okay? And with that, this is our first Corona episode. None of us has got it yet, so keep our fingers crossed. And kids, remember this all time, all day, every day. Don't be a mumu.